Okay, guys. So this week we're going to be talking about atoms. We're going to be looking at the periodic table. We're going to be looking how the elements are structured on the periodic table. Um, this should be kind of simple, more of a review than new content. If not, then hopefully, you'll understand by the end of this. I don't know if Mr. Green got to this last year or not before everything went crazy. Um, but we're going to start it off. So atoms, we have the basic atom model that you all have seen. This is the, an element on the periodic table. So these are actually what a model of an atom looks like based on what the scientists have seen so far. Remember, atoms are really small, they're tiny, they're microscopic. It takes a special microscope to see them. But atoms, so what is an atom? It's the basic building block of ordinary matter. Now, matter, that's like everything in the world that's not living, living and non-living. But when we get to human and animals, we'll be talking about their basic building blocks, and that's usually cells. So atoms, when we talk about that, we're talking about it makes up matter. So the basic unit of chemical elements such as gold, oxygen, and mercury. So the basic building blocks, so pure gold, pure oxygen, pure mercury, all of those are made up from atoms. An atom consists of three basic parts. These parts, you might hear them referred to as subatomic particles. They're just really small. So they're particles, but they're subatomic because they're tiny. They make up, even the tiniest of the atoms. And these basic parts are your protons, your neutrons, and your electrons. Now, your protons and your neutrons are in the nucleus here. The nucleus is the center of an atom. And your electrons are out here, and when you get more advanced chemistry, these are called shells, and each shell has an amount of electrons it can hold. But for right now, we're just going to say they're in their electron cloud. But these are the subatomic particles that make up an atom. So atom structure consists of a nucleus that we just said, that's in the center. So right here. It contains your protons and neutrons, and then the electron cloud, like we were saying earlier, surrounds the nucleus and contains the electrons. So these rings, like I've said, are referred to as orbits or orbitals. Some people call them orbitals. I've always called them shells. But you have your protons and neutrons in the center, and your electrons outside in the electron clouds or going around the shell that it's associated with. So protons are pretty much the easiest one for people to remember, because protons are positively charged. So, P for positive. They're positively charged. They're located inside the nucleus. Now, don't look at these colors and think, oh, a proton's red, or an electron's blue, or a nucleus is black. This is just so you can see the difference. So if we look, we have our protons in our nucleus. It's included in the mass of an atom. So mass, when we talk about mass of an atom, we're talking about the nucleus, because that's where the majority of the mass is. So one proton usually equals one atomic mass, but that's only partial of the mass. Neutrons make up the other part of the mass, and we'll talk. That's really important to know later on. But the atomic number that we'll talk about in a little bit is the number of protons each element has. And protons are important because they determine the element's identity. So when we look at the periodic table here in a minute, you'll see that carbon has 6 protons. It will always just have 6 protons, because if you added another proton, you would be changing carbon to nitrogen. So an element's identity is based on how many protons it has. If you add a proton, then you're changing its whole identity. Neutrons, they have no electrical charge. They're neutral. They are located inside, so we have our protons, but we also have our neutrons, which has no charge. They're included in the atom's mass. So like I said, the nucleus is considered the atom's mass. So you have your protons and neutrons that make that up. They may not always be the same as the number of protons. Sometimes you can have more neutrons. That changes the isotope, which we won't get into, of an atom. But you don't have to have the same number of neutrons and protons. So sometimes when we look at how to figure out how many neutrons is in an atom, sometimes it'll be the same, sometimes it won't. But that's okay. Neutrons are neutral, and they will change, and it doesn't change the element like the protons do. So let's look at electrons. So this is the third subparticle in an atom, and I'm sorry if it's kind of hard for me to judge if it's tilted or not. But electrons are negatively charged, so they're the negatives. You always have a positive and a negative charge in an atom. Now if you have the same amount of electrons as you do protons, they cancel each other out and there's no charge, which is mainly what is on your periodic table. Now when you get into your chemistry class in high school, you'll talk about bonding, and that's a whole different level of, electron sharing, stealing an electron, and that changes the charge of an atom. But for now, just think as electrons and protons are going to be the same number, because they're just canceling each other out on the periodic table. But electrons are negatively charged. They're located outside the nucleus, in the electron cloud or in the shells. They do not contribute to the atom's mass. So when we talk about electrons and the atomic mass of an element, they don't contribute to it. In a neutral atom, the number of protons and electrons are equal. We talked about that, so they are equal. And especially when you look at the elements on the periodic table here in a little bit, electrons and protons are always going to be equal when we're doing this type of stuff, looking at the periodic table. So speaking of periodic table, we're going to look at it. This table shows all the different atoms that are on Earth, and it's always changing. They're finding new elements and atoms, and but this is the basic one. This one's that are known and are legit, as you would say, to the elements. It's called the periodic table of elements. So this is like a table or a chart of elements. Remember, an atom is the basic unit of a chemical element. So you have, say, hydrogen here. Even though this is an element, it's made up of tiny hydrogen atoms. So if you have, say, a bunch of oxygen atoms, then they're all pure oxygen. That's an element. So even though it's like one box on here, there could be multiple atoms that makes up however much oxygen you have or how much gold you have. They're atoms that are built together to make that element. Some of these are metals, some of them are non-metals, some of them are gas. You don't really have to know that right now, but they are all made up of atoms. So the elements are built from atoms. So let's take a closer look at one atom or one element. And so what you're going to be looking at this week is we're going to be looking at the elements on the periodic table. We're going to be finding the atomic number, the atomic mass, the number of protons, the number of neutrons, and the number of electrons. And for the most part, if you have a few of those, you can figure out all of them. It's kind of like a puzzle. You have to think about it. But for right now, let's look at this element nitrogen. And so the element's atom's name is nitrogen. It's usually found under the symbol, and it's the name of the element. The symbol is usually the big letter you see, or maybe two letters you see. Hold on, go. The big letter you see, the number of protons is also referred to as the atomic number. So it is the number of protons. And the mass number is usually found underneath. Sometimes you'll have a decimal and a bunch of other numbers, but what I want you to focus on is the whole number. But it's located at the bottom most of the time underneath the name. It's the atomic mass. Now the atomic mass is, if you remember, protons plus neutrons, and that gives you the atomic mass. So also I want you to know the atomic number also equals the electrons, because remember, on the periodic table these elements are not charged, so they're neutral. So the number of protons has to equal the number of electrons as well. So if we look at this element, we are going to do it together. I'll try to get this focused here. We are going to locate the atomic number, atomic mass, the number, let's look it up, the number of protons, electrons, and neutrons. Okay, had to think about that one. It's too early this morning. Alright, so you can find out all of this information by looking at the periodic table. So by looking at this element, you can find that all out. So we said the atomic number is always up top, and it's a 7. The atomic mass is at the bottom. It is 14. And always just look at the whole number. Protons, we said, was the same as the atomic number, so it's 7 as well. And electrons are the same as protons in the atomic number, so it's 7. Now neutrons is where you need to pay attention. Neutrons, you can see, make up the atomic mass, but we've got to do this problem backwards because the atomic mass equals the number of protons and neutrons added together. So we will have to do a subtraction problem, and that subtraction problem is the atomic mass subtract protons and that gives you neutrons. So it's just backwards. So if we look at this one, our atomic mass is 14. We subtract the number of protons, which is 7, and that gives us 7 neutrons. Oops. So 14 mass, take away the number of protons, because that marks that out, and that just leaves neutrons. So the number of neutrons is 7. Now, like we said before, it might not always equal the same amount of protons. Sometimes it's different, so it's okay. But for this one, it was equal to the amount of protons. Okay, so what we're going to look at is we're going to do some practice here. And you might see a chart like this on your work this week, and I will give you a periodic table to look at. You don't have to go and hunt anything down. I'll give you this to look at. But for the first one, we're going to be looking at carbon, and it wants to know how many protons. So if we look on the periodic table and we look for carbon, it wants to know how many protons. Well, our atomic number is our protons, so 6. The next one wants to know the mass. Sorry, I know this is not in screen. So we got to look at beryllium, and most of them start with the letters, and sometimes they don't. And a lot of people ask me, well, why is iron Fe? Well, when they created the periodic table, that's when Latin language was big, and the Latin word for iron had Fe in it, so that's what they used. And they just changed the name of the element over time when they stopped using Latin language. So that's why sometimes they're different, and you kind of have to hunt. But then sometimes they're the same. So let's look for that element. It's right here at the top. And we are looking for the atomic mass. So the atomic mass is down here at the bottom. It's 9. Then we need to figure out what element has these. So if you look, like I said back in the notes, protons is the identity of the element. So if you look for an element that has 5 protons, it's going to give you the name. So let's look. And some of these are in order. So we have the hydrogen, and then helium is 2, lithium 3, beryllium 4, boron 5. So boron would be the element that has 5. So, and then the last one, we're looking for neutrons. So we have to do the math on this one. And we don't have to look at the periodic table for this one, because we have the mass and we have protons. And if you remember, the atomic mass subtract protons gives you neutrons. So if you need to write that down somewhere or take note of that, go right ahead. That's fine. So the atomic mass is 24. Subtract the number of protons gives you your neutrons. So the neutrons in magnesium is 12. Alright, so let's look for understanding here. Describe the structure of atoms, including the masses, the electrical charges, location of protons, neutrons, and electrons. So, what makes up the mass? Where are protons located? So, the mass is made up from protons and neutrons. The protons and neutrons are located where? If you said the nucleus or the center, you are correct. Electrons are located where? You could have said shells or the electron cloud or the outside. And then the electrical charges, protons are positive, electrons are negative, and neutrons are neutral. They don't really have a charge. The second, identify an element by its number of protons. So element's identity comes from the number of its protons. So for like carbon, always has 6 protons. If we look at calcium, let's do calcium. It has 20 protons. So elements are always identified by the protons, because if you change or add a proton or take a proton away, you're changing the identity of that element. And like I said, I will be giving you a periodic table to use. Feel welcome to print it out or just bring it up. This one for the mass is just the whole numbers, because that's all I really want you to use. Some periodic tables, if you look at, have the decimal point, but all I'm asking you to do right now is just to look at the whole number. We're not going to get into the decimal just yet. I hope this helps with your work. If not, if you need me, email me, call me. If you need a Google Meet, do a Google Meet. People, we need to be showing up for these Google Meets. They're not mandatory, but last week I did 2 worksheets on the Google Meets, and the ones that showed up got those 2 finished and knew that they were correct. So if you are struggling or having trouble, please show up to the Google Meets at 12 on Tuesdays and Thursdays. Or if you need help before then or after, email me and we can set up a time for Google Meet. And I will help you any way I can. So good luck on your work, and just let me know if you need me. Thank you.